Sam, this is Matsumoto's daughter.
Hello everyone. Thank you for coming.
And would you like to say a little bit about your father and what he meant to you?
Well, sometimes he was talking about his work, but we thought it wasn't so great because we couldn't understand at all. But now I met and thank you very much for this opportunity. And actually, he passed away 2 years ago. And before he passed away, Rob and Sho-san came, but he didn't want to meet new people because he was really scared. And maybe mentally problem, but he told us he got threatened and
Threatened.
Threatened.
Yeah.
So,
And when you actually look at his work, you'll know why.
Yeah, he was. Someone was following him, or he was really scared. Yeah.
He wouldn't take any food gifts because he was worried.
Then that's why he didn't want to meet any new people. But I met them first. Oh, thank you. I met them first, and Rob was really nice, I thought. Then I talked into my dad, and you should meet them. Yeah, and I was really surprised he retired many years ago, but he still had those stuff. So it was really lucky, and I'm really happy, and thank you very much.
Yeah, so before, I was told that he died in 2013. And I got to a point where I was reading his work and I thought, oh my God, there's so many important insights in here. He's listing all these other papers that weren't available in the public. Were they available at Hokkaido University? So I asked Sho, my good friend here, who has been helping me every time I've come to Japan. He invited me to come and work with Dr. Roshinamasa. Yeah. Who we saw, he's 86 and he was an absolute trooper, wasn't he, the other day, running an experiment. So he did all the hard work on radiation remediation attempts. So that was absolutely amazing. So it was a case of, I asked Sho, look, could you reach out to Hokkaido University and ask them if they've got any of these papers that were not published? And 10 days later, what happened?
10 days, not 10 days later. At first, we couldn't reach him because no records or something like that. And then the staff of the university sent a letter to Dr. Matsumoto. And then the Dr. Matsumoto read that letter from me, and then he wrote back to me with that original book. And I looked at the paper, but I couldn't understand, so I sent it Bob. And then he was very surprised to see the book.
Yeah.
Yes.
And the reason it interested me is I didn't hear this person's name mentioned once at any conference, in any paper, in my whole exposure up to, I went to the Sochi conference in 2018, October the 5th, 2018. One of the presenters mentioned this guy, Matsumoto, and what he showed on the screen was things that I had seen under the microscope and had also been mocked for by the Lenin community. And I thought, oh, there's another idiot like me. So I thought I have to get this guy's work. And well, fate would have it that he was alive, and we managed to build the trust just enough.
Yeah.
And I worked through the night to produce these images on the very last. So we had a 20-minute meeting, I think, with your father, and he was in tears, and you were in tears, and like I've never seen a man so happy that we have been able to replicate, and we didn't know we were replicating him. I don't know if anyone wants to man the camera. Here is Matsumoto's generation of carbonized film coming out of a ball lightning structure. And this is a carbonized film with an iron sphere at the end here. This is in 1997. This is in a plasma reactor. We have the iron spheres, the crenellated spheres, at the end of all of the carbon that's deposited here on a pure copper oxide and zinc oxide layer.
So can you explain what was your experiment?
In this experiment, it is a plasma chamber which Jan Rack replicated absolutely first time just last week. And David Boutelier replicated first time. And I've asked him to try and replicate this of Henk Uren in Holland.
Hello.
So it's a low pressure, hydrogen enriched, low pressure atmospheric air environment. And then it has some, it has some DC bias, about 200 volts, and then up to 700 volts of varying AC pulses on the DC bias. And you've got a more capable system, and we're going to have some fun with that.
Basically, it's like a
Yes, yes. So that's what we found, recreated what Henry did to create this. This was in his 1983 paper on nickel. It's the impact. And the form, exactly the form, every ratio, even the divisions is exactly the same. This is in a George Eagley ball lightning microwave-driven plasma, dusty plasma reactor. And this is actually on the body of the reactor, okay? The same form in every respect. This is in Henk Uren. This is in the plasma sheath where the structure has hit the plasma sheath. And this is in Matsumoto's 1999 work. This ball lightning image, we've got a much clearer version down there, and we can go even better than that because we've got all the negatives. We can produce these incredibly large images from his work. But this was actually taken from a video frame, and he stitched together video frames. We did this with modern technology. But this is the ball lightning. This is the fact that it moves matter around it, and it gouges a trail. This is in Lyons, nickel diamond.
So, wait, can you say more? That was this also a plasma experiment?
No, yes and no. It's in electrical discharge in water. So,
So it's electrical discharge.
yeah, so you're going to have plasma in there. And you're going to see that in video. Because we have all the videos that were going to be thrown away, but because I came along, they kept everything. And so we have all these. And you know, when you see it, he did a unique process. And I'll show you over there. But he took microscope objectives with a high quality video camera, and he's looking at like 2 or 3 millimeters of the experiment. So he's seeing a 1 millimeter palladium electrode or titanium or iron or whatever it was in a 3 millimeter field of view. And then he's recording that at 60 frames a second in 1990. It's totally unique work. And anyway, so this...
But let's slow down. That's here. So if you can see from video that this is really the ball lightning and this is a track, right? And that's evidence to this long-standing debate: what causes the strange tracks? Okay. That's ball lightning.
Yes, it's that all of that is done if people pay attention. It's all done, and in fact, he did it as well. So this is in boron nitride in a Parkhomov reactor. And again, you get the straight lines, but also the radial cuts. It's a very difficult thing to think about if you don't consider ball lightning a real thing. And here is again, this is in also in boron nitride, and this is in fused quartz in a nickel diamond deuteron Lion reactor by a guy in the UK who sadly died, Neil Crichton Gold. This is in Roy Shinamaza's cavitation, and this is in Matsumoto's 1993 presentation. You have exactly the same outer diameter and the inner structures with these bubble-like connections going on. Okay, so that is his... When we met him, we showed him that we'd been able to replicate without knowing he'd done it, and that third parties had replicated his observations without knowing that he'd done it first. And I think that's the best type of replication. So it was beautiful support based after he had been so roundly mocked. Okay, so a bit about Matsumoto's history. Over here, you have books like on neutron inelastic scattering, neutron lensing, the history of particle accelerators. Here we have what is this? Proceedings in nuclear transmutation of actinides. This is gamma ray-based transmutation of matter. These are all pre-Lena. This is what he was doing in the lead up. He was working at Kerr, a nuclear reactor. He was working at other research reactors in Japan, and he cut his teeth doing radiographic emulsions. He understood everything that you can see coming out of a normal nuclear reactor in radiographic emulsions. Okay, so this is the man we're talking about up here. You can come and have a look at him more closely later. But of course, during this pre-Lena time, he was traveling around the world, and he was going to these different labs. We have photos in many of the linear and different accelerators around the world with him participating in these different meetings. And so this is just a couple of images from him in London, obviously in San Francisco. You know, he was quite the fly guy, wasn't he? Okay, so now what he was incredible, in my view, is he was such a pioneer. He didn't try to do complicated, expensive experiments. He thought, what can I reduce this down to its bare minimum, right? It's obviously an electron process, and I think probably, I read the quote in his book. It says, far in the universe, nuclear collapses very often take place by gravitational force after stars consume their fuel. Since the electromagnetic force is about 40 orders stronger than the gravitational force, it should be easy to induce similar nuclear collapses by electromagnetic force in laboratory. But we never knew until now how to do that. Recently, the author discovered a nuclear collapse which was induced by electromagnetic force in the laboratory during the study of the so-called cold fusion phenomena. Several kinds of nuclear reaction were directly induced by the electromagnetic force called electronuclear reactions. They were found to so far to occur in a special state of hydrogen clusters called itonic clusters or micro-ball lightning. The nuclear collapse was one of the most remarkable reactions amongst ENRs called electronuclear collapse. Furthermore, very amazingly, completely broken materials by electronuclear collapse were found to be regenerated again to thin tubes and films of conventional elements such as carbon, oxygen, and iron. The latter process was called electronuclear regeneration. I'm going to go to the back end of his life in this field over here to a slide, which is in a part of presentation here I call A New Universe, and he sums up in here. He has all of the standard sort of universal things in here, like gravitational collapse, black holes, black and white holes here. This is a cold fusion star, and I didn't ever understand what this was. I saw the same kind of thing going on in the muon interaction from a neutrino in the Protvinov neutrino thing, where they had 7 cubic meters.
What are you talking about?
A muon created by a high-energy neutrino that Baranov shared in a recent presentation in the Russian Forum. It hit one of the Freon molecules in the 7 cubic meters of 20 bar pressured material. That came out and produced what he called, Baranov, a cold fusion star. And I went bing, because this is a cold fusion star, right? He calls it. This does not have a 70 gigaelectron volt proton accelerator. It doesn't have 49 meters of iron. It doesn't have 160 meters of vacuum chamber. It doesn't have a spark chamber. This is just a basic cold fusion reactor, and it's producing exactly the same thing, right? Out of a basic cold. And this is what you get.
So that means that muon is produced. That's what you are saying.
Possibly. Or something that's doing a fusion event. Whatever can do a fusion event, and the kinetic energy of the particles born out of that fusion event is what that is, right? You can make up the bit in between, but this is definitely something that he could recognize from mainstream standard nuclear interactions that were well accepted. And just before he started doing Lena, he had both of the 2 annual, I think the only 2 annual conference journals, they're this thick, and I've got them, of muon catalyzed fusion. So before he actually started doing Lena, he'd studied every single paper in muon catalyzed fusion. So maybe he recognized something there. And so here he has these electrodes, and we've got the videos. These are frames captured from the electrodes here, and you can see those evolve. But he says here, what is Lena? Okay, maybe I can get a bit of white paper behind this. He says, what is Lena? Well, we first thought that the Ptolemaic view of, the Earth and the sun's relationship, the sun's going round. Then you've got the Copernican, and we're going around the sun. Well, let's look at Lena. Are the deuteriums coming together? Well, I don't know. Maybe we need to think about it differently. Something is maybe causing them to be pulled together, Rather than them being smashed together, something is pulling them together. So he's got this thing orbiting around. And he says, this was caused by the Big Bang. This is the mini bang. And mini bang, Big Bang. And it turns out it really is producing the situation at the start of the Big Bang, in my view. But that's my view. But of course, every time I think I've ever found something, Matsumoto's already been there first. Okay, so, and then just to show, and I've got some comments up there, and I'll go back up there. This is ICCF26. He has a printout of every single ICCF, and he goes through every single paper and writes notes on them. I don't know another person in this community who comes even close to that level of due diligence. That is a man who really cares about the science. So, back over here. So, simple, novel, cheap, quick experiments. And then he brought to those simple, novel, quick, cheap experiments his expertise in radiographic emulsions. And I asked the community in Strasbourg if anyone had anyone in their teams that knew anything about how to do radiographic emulsions, and not one person put up their hand. So we have a whole field of LENA that doesn't know how to do one of the most important things to look for nuclear signs of nuclear events. It was a total shock. I thought maybe one or two would put up their hands, but no one knew anyone in their team that had any competency in radiographic emulsions. These are A4 plates. They're glass plates with the radiographic emulsion on it, and he's got a whole pack. He's got a whole pack here, he's got a whole pack here, he's got a whole pack here, he's got a whole pack here. In this one, he's got one lead brick, he's got 2 lead bricks here, he's got no lead bricks, and he's got some parallel to it. This is a man that's wanting to see, using his expertise, because the beauty of a radiographic emulsion, it accumulates things over time. It's not oh, I've got a blip on my thing, what does it mean? You've got actual signs on there. He then deeply analyzed the resulting materials. He gets we've got the actual radiographic emulsions. It's a 1 inch by 1 inch radiographic emulsion, not these ones, but he takes the 1 inch by 1 inch, he divides it into 4 quadrants, right? He then spent a whole day looking at one quadrant. And then he marks the coordinates of each thing that he finds. He draws it down and takes an actual emotion-based photograph of what's under that, right? So he has a logbook of what each emulsion that he's looked at, where he was looking at, and the photograph that resulted in matching the drawing. And then he thought about it. And in SEM terms, his SEM had a wet film. This is actually all of his photos. All of those are his photos, right? So this is the wet film. So we actually have, in this book here, I didn't know what he was going on about. Honestly, I'd like to have known what he was going on about. But he points to this image, and he's saying, oh, this is the decay product of these structures that are formed. Okay, here. Can anyone see what that is? No, I have no idea what that is, right? Because of the generations he had to go through with the printing technology at that time with his skill set in DTP. He did the best he could for the people he was trying to speak to. But the films are large format. They're large format, and moreover, you can scan them now at 16-bit, not 8-bit. So you can delve right into the data, rip it out of the past, and look at it in beautiful clarity, and we're going to look at that. Here is another pioneering technique he made. No one had done this. This is a high-quality video camera. On the front of it, he has put a microscope plan objective. He's looking at 20 times, 200 times magnification of a 1 millimeter electrode. A 1 millimeter electrode with a 3 millimeter field of view. And he's watching on the VTR whilst recording it. Okay? He can see, and I've got all the videos. Like I say, he was going to throw them away. I'm going to show you here. You can see the process working here. So that is the electrode to start with. He's got a DC on this, and he's going from 0 to 40 volts. And you can see the evolution of the gas. This is the cathode. And he describes this explicitly. Up to 40 volts, you start to produce electrolysis. At the point of 40 volts, you start to get these little plasma things coming at the end. And then between 40 and 60, the plasma structures take over, and the pinch effect suppresses the evolution of the gas. Now, why is it suppressing it? Well, he would argue the hydrogen that's being evolved or rather the hydrogen that's coming to the cathode from the gas, is then being pushed into the clusters because of the pinch effect. And you start to see the illumination here. This is 1990 or 1991. And it's being ripped from the past, these beautiful images. And when you slow this down, you can literally see these hydrodynamic vortices of these plasma structures leaping off the electrode, right? Now we're starting to get in the 40 to 60 thing. And when he gets into the range where the gas is being suppressed, which is about 70 volts, he'll turn off the lights. And you can really see the magic. Yeah. There's like 30 or 40 videos, and they're hours long, of different experiments with different configurations. Very simple, rapid cycling.
So you're saying that the pinch effect, so the magnetic hydrodynamics is suppressing gas from...
There is a paper by a Japanese author from a Chinese author that was published just 1 or 2 months after Pons and Fleischmann's announcement. They said that it's the pinch effect on the tip of the electrode, which you literally can see here. And they replicated Pons and Fleischmann within 2 or 3 weeks with this process. And they called it the pinch effect. And they said it's hydrodynamic vortex. And they put they take a galaxy image and they put it on the end of the tip of the electrode. And they say this is a vortex in the ether that's forming a coherent structure in 2 weeks or 3 weeks after Pons and Fleischmann. So you can see it here. So what he then found was, and this is where he got roundly mocked for his terminology, this is natto. And Sho, would you like to describe natto beans for those that don't know?
No, please.
Okay, since he showed me.
Fermented soybeans.
Yeah, so you actually get a pack, you get the other bit, and you mix them together, and it becomes this sticky glutinous thing, and it's really yummy. Anyway, it comes in these polystyrene-like packs, and you mix it together in there, and you let it sit for a bit of time, and it ferments. And what he did is, this is a broken up cluster that has formed in his experiments. And it's broken up, and this is the spilling material that's come out. And he's literally taken the natto beans and tried to spread it out. I've got it rotated the wrong way to match this. These are the typical elements you see synthesized in Lena, right? And these are the strands, possibly, and I would argue, they're spat out of the arse end of the smaller structures that are inside the bigger structure. Because after Binge-Ren Huang's data, you can see hydrodynamic structures going into this overall sphere, and in there you've got loads of tori, and in there you see these little balls. So I think he was right. It's just his vision of how to get this across to people didn't play well outside of Japan, and was actually quite mocked in Japan, right? Unfortunately, but it seems to be real. And then the other thing is, he was not afraid to address unexplained phenomena. He would go out and say, why is a volcano a volcano? Why is an earthquake an earthquake? You know, we see these, Sho sent me an image from an earthquake with the spiral cloud coming out of the ground, which he identified in one of his work. And this is a sign of the ball lightning coherent vortex structure coming out of the Earth, and it's a neutral structure, and we'll get on to that in a minute.
What did he think of crop circles then? That's a bit of a crop circle.
Yeah, he actually visited a couple, and he imagined that the vortices that he was seeing in his system, that caused that thing on his ball lightning track might be what's going on. And I think he's right. I would agree with him. Within his capacity, he left no stone unturned. He read past literature and analysed all of the proceedings, as I said, for those that weren't here earlier, of contemporary colleagues. Unique. And he learned from and presented to conferences outside the Lena community. I've learned this from Matsumoto. I switched to speaking to very much larger audiences who are very much more passionate about learning about interesting technologies and ways of thinking from this guy. So thank you to your father.
Oh.
Right. So back to that image that I could not explain in here. Back to that image that I could not explain in here because I couldn't understand it because the quality of the image wasn't that good. Tearing these things out of the past, out of the dustbin, right? Thank you to your family.
Thank you for taking our dust.
These are his words. When the iron wires were used for the electrodes, tiny ring products were successfully caught on the surface of the cathode. What does that tell you? Yes, but what does it tell you?
So it was electricity going.
Okay, what did I say? When iron, ding! What does it tell you? That they are magnetic structures. With other elements, they did not bind to the electrode.
You mean that these ring things are...
The ring structures could only be caught by iron.
Because of magnetism.
Well, I'm just not using much. I'm using my preschool level of mental thinking, right? To go, that's what he's trying to tell me here. Similar to structures on Henk Uren's Vega plasma experiment anode sheath. These hexagonal and pentagonal structures, they are observed in various places in the Vega experiment. You are going to see them. I guarantee you 100%, and I will bet you $1,000 right now that you will see them. Okay. Yeah, you don't want to take that bet, right? These things, he says, the image below shows an intermediate stage of decay in which inner circular zone is still remained. After about 2 days, these toroidal structures decayed into these hexagonal plates. And the synthesized new elements in the reactor, which did not exist in the material before, are only in these hexagonal plates, in addition to the material that was in the reactor to start with. So I've given a whole series of QR codes here. Like the QR code to see the verification here. This is monopoles bound to iron 57 decayed after 2 days in Leonid Eruitskiev's exploding metal foil in water experiments. There is the link. There is the QR code for you to go and look at the evidence. Observations of long-lived toroidal plasmoids by Bogdanovich et al., Moscow Nuclear Physics Institute in discharges through water jet lasted for around 2 days. Water jet, 200-volt bias, DC multi-thousand volt shocks, the same that was used in sort of process that was used in many different experiments. Metal plate, glowing plasma structures caught on video moving around, toroidal, glowing 2 days later. How is that even possible? Well, I have a good idea, and you'll have to come to my poster session on Thursday to tell you how I think that's working. But that's what he saw. Here, reductions of the ability of the medium around Anatoly Klimov's plasma vortex reactor to pass gamma rays, which lasted for around 2 days. So he did his plasma vortex reactor, ran it, and he had a gamma-producing source, and the gamma detection was suppressed for around 2 days after running the experiment. I could go on. I have a list of different experimenters, completely independently, reporting 2-day phenomena, right? But Matsumoto was right there at the start. There are so many examples. Now, same experiment, family, down here. Unique use of nuclear emulsions, as I mentioned earlier, showed that ring-like products could act as neutral structures that could walk through matter. This is his words. The traces suggested that some particles walked around on the surface. There's a lot more traces. This is just a little bit of a trace. The figure to the left, that's my words, shows a ring product that the extraordinarily rail-like traces were generated by the ring products that escaped from the cell and walked around on the surface of the first nuclear emulsion. The diameter of the ring was about 10 microns, which was approximately the same as that of the ring products observed on the iron electrode. This observation suggests an extraordinary result that the ring product could penetrate through the glass wall of the beaker and the water solution. It took until an interview by Nancy Lazarian with John Hutchison and Kenneth Radford Shoulders in 2010 for that same discussion to be had and put into the public. This is in 1996. What is happening there? These structures which were binding on here, some of them didn't get caught because they leapt off like you saw in here. And they went through the solution, through the glass, through the air, through the packaging of the nuclear emulsions, went along here and left this trace. Now, he doesn't mention it, and this is the gift of Matsumoto. He only says what is necessary to prove his point. But I'm telling you right now, what do you see here? The shape, it's a hexagon, right? But here we have 120-degree sections. Here, 120 degree, 120 degree, 120 degree. Down here, 120 degree. He's not wrong. He's not laboring the point, but the evidence is, to me, totally and utterly conclusive. This can produce neutral structures that can walk through matter. So, they do not interact with non-magnetic material, but they do with magnetic material. All in 1996. So much in this one paper from 1996. It is a goldmine of all of the things that people think they found since. Just one phrase. Maybe I'll read you some, but I want to show you around the rest of the room so you can take in your own time. So this is pre-Lena. This is the original documents in this group sent by Edward Lewis with his signed letter in February 1993 that put Takaaki Matsumoto onto the idea that it might be ball lightning that's involved. Okay? And so he's got the original marked up by Ed Lewis patent of Ken Shoulders, another patent. He has several original documents from Brilliant Light Power and so on. So he grouped those together, and I call this the Lewis Eagley Shoulders Mills ball lightning package here. Then he met George Eagley, and George Eagley sent him his books on his 1970s and 80s studies into ball lightning, and he takes some images here. And then he shows some things that he sees, and I shared some of these structures in my presentation in France, or wherever it was. These are the ring structures, which are rings of rings. But you can't really see it here, but we can pull this out of the past, and you're going to see these beautiful in the new version of the book. Over here is the original draft. He's trying to assemble the book. He's got bits that he's cutting out and stuff. Here are some his images that I spoke about earlier, and that particular paper there. So knock yourself out. And over here are some of which the family have given me, which is very generous. He loved owls, and so do I. And the thing is, when I walked into his house and I saw these two images, I couldn't believe it, because everywhere I had gone when I went to Hokkaido, I kept seeing owls. An owl is the structure of the magnetohydrodynamic vortex. It is the symbol of Delphi. It is the animal version of the symbol of ball lightning, which is the double epsilon. Okay? And it's the secret to how all of this works, and it's written in our faces. The technology that runs the universe, we are built in the image of it. And in his latter life, he decided to paint these book reading units. And if you want to bid for one of these, I'm not sure I can carry them all home. So it would help with the MFMP's research. If you like a particular one, Hiroka-san has said she will sign it. His subject is there and the date in his handwriting, but I'm afraid you're going to have to do with my signature and or Hiroka-san's to give it its credibility. Okay, so any questions? If anyone wants to look at the many videos, I'll be going through all the kind of different videos from his experiments. These will all be published. In the PDF version of the document, I want to link the videos so that you can go through the document. You can literally see the video that produced the data. And I'm going to be publishing the analysis logbooks and the experimental logbooks as well. So you can see exactly what he did, what he was using, the materials he was using, where he was buying the reagents, and everything. Absolutely everything. The amount of time he ran the power cycles for, every single thing is described, and then the same for his analysis. The level of methodical analysis is absolutely incredible. Any questions?
Yeah, so what is the conclusion about the ball lightning composition? So if it goes through matter, then ball lightning doesn't comprise electrons. So or
it's not presenting the charge in the same way. It's lost the charge function. Or it's not in the same wave function that interacts with ordinary electrons. It's like 2.45 microwave is not attenuated by a wall, whereas 5 gigahertz microwave is more attenuated. So I think of these things, if you create a coherent matter wave and the structure is a vacuum analog, an exotic vacuum object rather than a normal vacuum object like an electron, proton and neutron, those live in our vacuum. But if you create an exotic vacuum object, they can walk through the elements in our vacuum.
Right. So I'm a little bit following what you're saying. So basically, it's not that it does not contain electrons, but it contains electrons in a different state.
They're reorganized in a coherent state that produces a continuous wave function that presents as an exotic vacuum object. It has its own space-time, to use that, and it can literally walk through things. But it does have a magnetic moment, and that's how it can feed itself. And it does have a toroidal moment. It actually has a fractal toroidal moment. But it just doesn't interact. It's like, it just, or if you had, you don't fall through that floor because all of the electrons in your shoe are the same vacuum objects as the electrons in the ground. They repel each other. That's the only force we know, right? But these structures, an exotic vacuum object like a normal ball lightning, can walk through glass. It can walk through metal because it isn't running by the same rules.
But that is the question to understand.
Well, it's definitely not running by the same rules. He's not the only person. We've observed it. He observed it. Svyatomenko observed it. Who do you want to talk about? They all observed it.
Right, but we observe, but we don't know in the end exactly what it's made.
I think it's this.
And but then where do magnetic monopoles fit in? So that does it also contain magnetic monopoles?
I would argue it does, and certainly his work shows evidence that it does.
Right, but it's not only magnetic monopoles.
And so, sorry, can we clarify? I don't think anyone thinks it's a real monopole, but it is a Dirac compliant monopole like Wisniewski's 2008 model, where the overall hydrodynamics produces a vortex, and in that vortex you get the electrons coming into phase synchronicity, producing Cooper pairs. And they then come to a degenerate ring singularity, and that produces a continuously increasing magnetic field.
Yeah, but
that's Wisniewski's model, and it's cited by Bogdanovich et al. As a potential method to explain what they observe, which really happens under the microscope, moving around for 2 days, glowing on a piece of metal. So they cite that.
It's almost the fifth state of matter.
It's a new state of matter.
Yeah.
And very specifically, and I will go walk through everything in my poster on Thursday, it is very specifically,
Plasma is 4 and this is number
it's a
5.
very, very specifically an electron quark gluon plasma, plasma toroid, plasmoid. And that is exactly in Bogdanovich's book. And in 2011, one of the last notes that Ken Shoulders wrote before he died in 2013, early 2013, was that it is the prima materia, it's the mother of all matter, and he cites that Svyatomenko's work is quark soup, which is an abbreviation for quark gluon plasma. And only with a quark gluon plasma with electrons in a cloud can you produce the magnetic fields to sustain the magnetic strength to do the vacuum photon depletion to initiate the process.
It's a new state of matter will make...
It's not a new state of matter, it's actually quite ubiquitous, and it probably is why consciousness occurs. When your consciousness switch on, you kind of spin it up in your brain.
Sure, but for the public it's easy to explain it this way.
Yeah, they'll come along maybe 30, 40 years from now. They'll get there in the end. Is that your questions?
Yeah, well, that was my question. Yes,
Okay.
if you know what it's made of, yes, okay.
Yeah. So basically, what happens? You build a magnetic strength, and that can occur through Wisniewski's method because you don't lose it, or it can occur through Nevesky's extension of Maxwell's equations in 1988, but published in 1993 in the Electricity Journal, or you can in Russia, or it could be the David Freiberger SLAC that's published in 2009. But in both cases, it produces an intense magnetic topological monopole, and as John Kramer said in 1983, when you get above a certain threshold, it causes baryons to fall apart. And very specifically, in Svyatomenko's book, it very precisely says when you get a sufficient magnetic strength, it causes color disconfinement of baryons, and they become quarks. It separates them out. As you pull a quark out, the vacuum gives it an antiquark. It produces a meson. They go in, because they're charged particles, that produces a magnetohydrodynamic structure out of the quarks, and that makes a structure, but but you can get the magnetic strength at 0.672 microns or a nanometer, which is compliant with the pattern of Ken Shoulders for the minimum structure of an exotic vacuum object, which needs to be around about a micron, and they fractally scale up into bigger clusters, and that can maintain the magnetic field, which does not deplete, when it can pull in. Basically, you've got a vacuum sucking in photons, right? Because it's dragging in the thing over which photons transport, right? Faster than the photons can come out. So it's pulling them in. If you've got a piece of matter below that, you've got the photons and the dark matter being pulled through that, it gets dragged towards the structure. When it comes across the event horizon, it does the color disk confinement and goes into the core. But it doesn't need to go that. You're still getting all the atoms coming in. And Binzhu Huang's analysis, and anyone can ask Binzhu Huang for material, and you will see in just a couple of millimeters everything you need to know, that a wheel within a wheel within a wheel, the sacred geometry, the magnetohydrodynamics of this all can do this process.
Question.
Yeah.
There are at least two flavors of plasmoids, Ken Bostic's original concept, and then Les Dreitner's condensed plasmoids. And do you have any experimental evidence to decide between the reality of either of those?
So here's the thing. Lutz Jaitner refers to the diagrams in the 1957 Bostic paper as this spiral structure with a loop on the end, coming out of a point of focus, right? Now, the interesting thing is, Winston Bostic's original experiment was two deuterated titanium electrodes in a ceramic. They put the 10,000 amp nanosecond or small pulse through. That produces a plasma loop of whatever, titanium and deuterium ions and electrons. That comes off, and the loop is then drawn, magnetically reconnecting. And then they come towards the center with a magnetic field to cause them to orbit around each other in the center. And you know what he does? He then draws them not as magnetically reconnecting. He draws them like Lutz Jaitner's strands twisted with a loop and the tail coming out. And it's bizarre. I don't know whether it was deliberate, but he says he's very careful in his writing. Between each description of image, he gives himself a get out. He says, this is an example of what it might be, right? But they already did the experiments to show that it is a torus. So it is a tori of tori that come together in the center, and that is what it is. That is what you see. That's what Matsumoto sees. That if you see the classic pinhole camera of Ken Shoulders, you see the structure, the Evo coming up here, and it's two things orbiting around it, just like the plasma structures in the plasmatrons of Klimov in the 1970s and 80s. And that comes up, and as they start to decouple, they come apart. You can see that in Binzhu Huang's reactors. You see the two fractal tori structures, and they've come together, and they crash down onto the copper, and this one breaks away from its pair, and it's got pure copper wrapped around the outside of this 20 micron structure. No, 20 micron, as observed by Ken Shoulders, as observed by this guy, right?
So
Matsumoto.
there's no difference. You're basically saying the Jaitner concept and the Bostic concept.
No, Jaitner calls it, he shows it as a braided twist. It looks like a braided twist when you do a persistence of vision, either in an eye or a camera. That's what it appears as, but it's actually two objects that are orbiting around. And in the analysis that we've done on Huang's reactor, we've seen these structures break up, and we've seen that they can leave behind matter that they've consumed in a twisted braid. Now, if you saw that matter coming out as a twisted braid, you would think that that is the structure, but it's not. It's the guts spilling out of the structure that ate that material. Okay.
Is there a comprehensive list of all the references?
Of what?
Of all the works that you cite? Is there somewhere?
Every video that I've ever produced, I put the references with it.
Be written, okay.
Sometimes I do it over and over again, because it's the same references. I refer to Matsumoto all the time. Yeah. I refer to S.V. Adamenko. If you want to know how this works, look at S.V. Adamenko's book. Okay. It's 750 pages, but
good. But yes,
I worked this out from what I saw under microscope.
Can be read.
And then I thought, I'm sure someone must have thought of this before, and then I see Ken Shoulders, that was his last comment on the matter, right? And then I look at the book that I bought years before from S.V. Adamenko, and on page 150, you know, there's two aspects to this. The field will cause, and you'll see it in my poster, it causes cluster decay. It's not fusion, it's not fission. Fusion is this. Fission is this. right? This is deconfining, as I showed in my presentation in Strasbourg. Like I took that deep sea fish. You pull a deep sea fish from a couple of kilometers down, it comes up, it turns to jelly, mush, because it doesn't have that pressure from the environment. Ordinary vacuum objects live in our vacuum, which has 10 to the power 112 joules per cubic meter, or whatever it is, of 0-point energy. and when you start with this structure, dragging the thing over which photons travel into the core, the photons can't escape. And you have a low pressure in the vacuum above the matter, and you have a high pressure below, and you get a flux going through the matter. It gets overexcited, it's non-thermal, it causes it to fall apart in the ratio of strengths all the way up to color disconfinement, from van der Waals through polar, through like ridiculous. And so at the lower levels, when it's spun up to a low level, it will start pulling in clusters off atoms. So in the Marsa gas on tungsten, it starts ripping off carbon and oxygen. The carbon gets deposited, the oxygen goes away, and you can see it where it's doing it. So the carbon comes in, but also other fragments of matter comes out. So the carbon orbits around the structures. It doesn't typically go in except to the central core. As the clusters go in, this is said specifically by S.V. Adamenko, you get a core, which is this structure, which is this structure, which is what caused this, and it goes in its arse, it feeds into its arse, right? And what goes into there, and you can see exactly clearly on the Binge-Huang analysis, are substructures that are self-similar to the toroidal structures you see over there, which you can see in standard hydrodynamics. They go in and they form exactly what, on page 150 of S.V. Adamenko's book, electron, nucleus, nuclei, when the nucleus is completely bare, because the electric field strength of even a simple laser into plasma is trillions of volts per meter. So all of the electrons get ripped off. You get a bare nucleus in there, you get nucleons. The easiest nucleon to get, because it has no binding energy, is a proton from a protium. They go into the core and it builds up. And Adamenko totally nails it. He says in that core, dark matter assists. This is a paper in 2005 in the newspaper. Dark matter assists, but dark matter is such a flux going in there to assist with weak interactions. And then he has, he says it produces iron, and then iron forms, iron forms, iron forms, iron forms, until you go past what he defines with the mathematics, a critical threshold of nucleon, nuclei, electron, gas, macrocluster, and then it starts synthesizing all of the elements in the periodic table, and Vysotsky can attest it produces up to thousands of AMU elements, right? Yeah, it does. And so that is what's going on, and the reason you see these iron-rich crenellated spheres, it doesn't matter what experiment you do, this is what you see. All of them will produce this. Because iron is the first, and sometimes the iron is ripped out of the material that the reactor's made from. Yes, it hasn't been transmuted. But how does a little ultrasound experiment, the water's still at like 20 degrees, how does it produce a smooth, fused iron-oxygen structure? When it took a diamond anvil and what is it, 760 gigapascals at 1,700 degrees to produce FeO2 in 2017 in China. There was none of that going on in that $35 ultrasound experiment. So that is what's going on. You will see these. You just have to bother looking. Just have to bother looking. Do you have another question?
Yes.
Oh.
There is something I don't understand clearly.
Mm-hmm.
With your rings, with a lifetime of 2 days, you know.
Typically, in multiple experiments over many years, independent authors think they've independently discovered it, yes?
Yes, okay.
Yeah.
But if you see them, it means that there is an energy exchange with the ambient, you know.
Yes. And do you know what that happens with ordinary atoms?
And how can you keep an energy exchange for 2 days with such a tiny object?
it's spun up to a certain level. And I think Jan Rack's smiling now because he knows that quark gluon plasma is the most superfluid thing that has ever been discovered by, sorry, for your sake, mainstream science. Right, Jan? That's right. The most superfluid thing. So if you create a magnetohydrodynamic structure out of this rather than electrons and plasma, firstly, it doesn't have to be over 1 millimeter to produce the required 10 to the power 15 Tesla field to do the color disc confinement, right? It can be 0.672 microns.
Running out of time.
That's okay.
No. For the conference, and they need some time
To look
around.
Oh, okay.
Well, maybe because there was new people arriving, maybe you just do a quick introduction.
Okay, yeah, sure, yeah.
Because,
So those people that want to look at things, go for it.
This is one of the most mysterious and controversial objects in the world. A crystal skull called the Skull of Doom. It's the inspiration for the latest Indiana Jones movie. And the man who made it famous was a real-life Indiana Jones, a flamboyant adventurer and buccaneering archaeologist. His crystal skull and a handful of others like it have given birth to a legend that has caught the imagination of millions worldwide. According to the legend, 13 ancient crystal skulls from a lost civilization